and they throw in a lot of unique examples. They take pride in giving something you've never seen before. And last year's exam, they did a really good job of that. It was the hardest exam they've had in the last 5 years. So be prepared. Okay, so on this first one, whenever I didn't show my work because I'm figuring out you guys don't need me to show everything. What did you guys set up for part A on this one? A, number 4. PV equals an RT, right? Plug everything in. You got your moles of carbon dioxide? Yes, yes?
Yep.
You got 1 point for getting that part set up with the correct answer. And then you got a 2nd point for using that information to get to grams of carbon dioxide, but this one had to be recorded to correct sig figs. Who was the limiting one? I think it was 75 mils of carbon dioxide. I don't have it right in front of me. 750 millimeters of mercury. Right, it was 750, which is only has 2 sig figs. So that was your 2nd point. Second, B, you had to write down 2 BCEs. If you got both of them, okay. Carbonates make carbon dioxide whenever they decompose. If you didn't put the triangle over top, it's totally fine. You just had to have correct reactants and products. That was 2 points. Who's 4 for 4? What? All right. Next question said it gave you determine the initial. Sorry, it was also determined that the initial sample contained 0.0448 grams of calcium. What percent of the limestone was massed by calcium carbonate? So if you started off with this much calcium, and you know the calcium was in calcium carbonate, then I just went straight to calcium carbonate to figure out exactly how much calcium carbonate was in the original sample. The original sample, so calcium, showing all your work. Okay, I know it's tedious, but you can do it. Molar mass, internal mole ratio, grams of calcium carbonate gives you 0.112 grams of calcium carbonate. But then that was not the right answer. It said the percent by mass. So out of the total sample, they gave you the limestone. This was the limestone sample. So you take that over the total and you got 40%. Okay, the points for that came into play. 1 point for whatever your answer was for this first question, for the first part, and then 1 point for your final. So if you happen to get the wrong answer up here and you used it down here, you still got 1 point out of 2. Because you used it appropriately, even if it was like the wrong answer up here. So they like to give you credit for process. Part D, who realized what they were asking for? When I said magnesium containing product, you just had to read between the lines. It's asking for magnesium oxide because that's the only product containing magnesium in that decomposition. So it's really asking for that right there. So when you start with your information, the only thing you have left is you have the sample initial, you have the grams of the calcium carbonate that you just got in part C. So from that original sample, you should be able to figure out how much magnesium carbonate was present there. Well, that's subtracted. You get 0.168 grams magnesium carbonate, and then your job was to get to the magnesium containing product. In that case, it was magnesium oxide, so molar mass, mole ratio from BCE, and then molar mass again for magnesium oxide, you got 0.8803. So points on this one. You got 1 point for subtracting to isolate the magnesium carbonate, and then 1 point for your process to get to magnesium oxide. So what many points was that? 2, 4, 6. You got all 8. You got 6 out of 8. Okay, awesome. So that's not incredibly challenging. And how much of that was gas laws? Not much, right? You'll notice that gas laws are really embedded with other stuff. So there are very few that are purely gas law related questions. Keep working over, and we'll go to number 6 after I write it down up here. Oh, before I forget, who's interested in taking the Socrates quiz as an assessment in class? Who just wants to take it for study evidence? Maybe I'll open it for the rest of the day. Okay, so those of you who are going to take it in class, I'm going to ask you to start around 8. Okay, that's in like 15-ish minutes. If you want to take it in class, I'm holding you accountable for that grade. If you want me to add it to Unit 3 lab grades, it will help that average if it's a good grade. If not, just say I'm using it for study evidence if it doesn't hit your grade. It's a win-win. I'm not going to hurt your grade on it. Huh? I think it's like 20 questions. Huh? I'll look again. No.
You said no.
Yeah. Yeah. I'm gonna go over number 6 real fast, and then I will. I'm just checking how many questions I said. 16 questions. I'll look again then. Because I wrote down each one in one, but maybe it was 2, and I just need to look back at my stack. Okay, I'll look again. Because that was yours is the only one I had a question on. I'm pretty sure I turned it, but I wrote down 1, so that's why. Okay. Number 6. You will have a question on your FRQs like number 6, by the way. Just FYI, you will have a question with explanations, but I'll write them on board so you guys have some information. o'clock in the morning is the
It's the
question.
same person from Texas.
How about you block it? Because I'm going to take your phone next time.
That or you turn off the ringer, dude.
Or just turn it off. Or leave it in your locker.
You don't have to for your house. What? For your house. Why would I leave it in my Don't you need it?
Alright, not Cinco. Number 6.
I said recommend.
I'm gonna go over the whole thing. Sorry. Okay, so like I said, you will have an explanation-based question. This is a lot of detail because I want to make sure I covered the whole gamut. But I expect you to put some level of detail in there because especially when it says explain, it does mean explain. Do not just put because one thing. Who got the carbon dioxide is going to be highest in mass. Okay, you know they all have the same moles, but that's going to be based off molecular weight. So that was a 1 point question. That was easy. And it's nice to reference the molar mass of it just to say like, hey, I actually know the molar mass and this is why I said this. Second, all of them would have the same kinetic energy. That's ugly, but it's average kinetic energy because they're all at the same temperature. And then further explaining that kinetic energy is directly related to Kelvin temperature due to the KMT would be kind of nice as well. I tend to explain more on these types of FRQs because sometimes the rubrics are a little bit too narrow, too specific. So it's nice to have a bit filler so that you make sure you get your points. That was 1 point as well. Third, which would deviate most, and so my explanation stretched this far. You can see it's like 3/4 of the page because I covered the entire thing, but I wrote a lot of it here just so you're aware of how you can explain this in many ways. Carbon dioxide will deviate most from the ideal gas behavior because it's heaviest. So we have 2 factors. You're looking at molar mass and you're looking at polarity. It's heaviest, so and then I noted all their molar masses. You don't have to do that, but your statement here kind of qualifies that. And that's going to increase the likelihood of increase the volume that it's taking up, therefore it's going to limit the volume that it can move around in. So that's where mass comes into play. But all these molecules are nonpolar, so then you're like, oh, well, that polarity part is not a factor. Sometimes it's not, but in this case it has a little bit to do with the pressure component of the ideal gas law, or the real gas law. So if they're all nonpolar, they all experience London dispersion forces. If they all experience London dispersion forces, the rule is the heaviest one has the most it's polarizable. We're going to talk about that later in the year, but it has the most likely attractions or the ability to attract. So if you have the most attractions, then you actually limit the number of collisions with your container wall, therefore limiting the pressure, which causes deviation. So where the 2 places, what 2 variables do we see that cause or reflected in the deviations? What 2 factors or variables of gases do we see deviations from? Mass, which relates to volume, and polarity, which relates to pressure. And that's why we saw that real gas law with an addition on the P and addition on the V, not the NRT. And then lastly, which would have the smallest balloon at the end? That would be helium because it's the lowest molar mass, it's got the highest rate of diffusion, and you could even relate that back to the kinetic energy equation, 1/2 mv squared. Smallest mass, highest velocity, therefore it can diffuse the fastest. Okay, that was worth both. This one may have been worth 2 points. This one may have been worth 1 point. So 5-point question. We got 4 or 5? Hey, okay. So you got time? Keep working. I'm gonna stop your quiz in just a minute. I just gotta pull it up. Okay. If you need to separate yourselves to the computer or whatnot, go for it. Because it's faster or slow. Square root is equal to square root of molar masses. Like this. This relates right here. This is 1. This is 2. It's going to be square root. Okay. So since everything's the same, assuming same pressure, you would be able to moles in the array of for gases if they're on the same temperature or atmospheres or whatever. So in this case, we're actually it's just Is this what it says? 1 atmosphere of this?
And then one atmosphere
Of E. So who's limiting? Who is limiting?
Oh, B.
So that divided by 1 is 1, that divided by 1 divided by 2 is. So who's limiting? Minus 1 ATM in a ratio of 1 to 2, right? 0 plus 1 ATM in a ratio of 2 to 2. 0.5 and 1. So the total is 1.5 ATM. See, we just basically did a BDA table. Is that, you got it?
Yeah, thank you.
So, or is it actually, is multiple choice actually due